One last skill we are going to use in this section is on our graphing calculators, finding the vertex of a parabola on our calculator. So we're going to do, this is actually number 39 on page 199 in your textbook. The equation for the cost in dollars of producing computer chips is C equals 0.000015x squared minus 0.03x plus 35, where x is the number of chips produced. Find the number of chips that minimizes the cost. What is the cost? Now we see this word minimum. So think about when we have a parabola. I know this is going to be a parabola because I have x squared. When we have a parabola, where on the graph is our minimum value or our maximum value sometimes? Hopefully you're thinking it should be the vertex. And right now we don't know how to find the vertex of quadratics, and this is standard form. We don't know how to find this yet. Maybe you remember from Algebra 1, but I'm going to guess probably not. All right, one thing that we can do though is to use our graphing calculator and use that tool effectively. Remember those mathematical practices. So what we're going to do on your graphing calculator, oops, there we go, I'm using my Wabbity Moo here. I am going to go to y equals and type my equation in. And then there's 4 zeros, 0.000015 x squared minus 0.03x plus 35. Okay, and then I'm going to look at a graph. And we might have to play around with our window a little bit in order to find where our graph actually is. So I am going to change my window. And I know X is talking about the number of chips, the number of computer chips that are produced. I don't think we probably really need any negative values. And then my X max, I'm going to start off with 100. We'll see if that's enough. Okay. And then don't forget about that zoom fit trick. So whenever we figure out what X values we want to use, let's change our Y values accordingly. So zoom fit right here. And that way we don't have to mess around with our Y values to find something that works. Okay. Let's try making our X max 1,000. Oops. And I should zoom fit this also. And we can always overshoot and then come back to it. All right, now notice how my graph is leveling out here. That makes me think we're getting pretty close to our vertex. Let's go a little bit farther, maybe 1,500 for X max. And then zoom fit again. And there it is. So we can see our vertex. Now here's our process for finding it. So to find our vertex, we go to second calc. And what do we want to find? We want to find the minimum. Okay, so I'll write that with my pen here. Second calc minimum. Okay, now notice how it says left bound here? That just means we want to be on the left side of our vertex. So I'm going to put my pen here. When my pen is kind of over our axis of symmetry, when it says left bound, my cursor needs to be to the left of our axis of symmetry, which it is right now. Hit enter. And then when it says right bound, we need to go somewhere to the right of our axis of symmetry. And we don't have to go too far over, but just make sure that you are on that right side of your axis of symmetry. Hit enter. Yes, you can hit enter again. I just like to go back a little ways normally, but it doesn't really matter. It's kind of hard to tell, but here we go. Try to move this. You can see those vertical lines where I did my left bound, right bound. Okay, guess. And here we go. Okay, so it tells me my minimum is 1,000, 1,000.0001. That's really just 1,000. Sometimes calculators do kind of weird rounding things. The y value is 20. So 1,020 is my ordered pair for my vertex. And I should just say my vertex is 1,025. And as far as the number of chips that minimizes the cost, what is the cost? Well, my x value tells me the number of chips. This is my cost. So I'll write that out in words. The minimum cost is $25 when 1,000 chips are produced. So throughout this year, we are going to learn how to use a lot of skills on our graphing calculators and make sure we know some different strategies that help us to use our technology effectively. And this is one of the ones that we will use a decent bit along the way. So there we go. We'll add that to our toolkit.